Okay, so now let's talk about convolution. Convolution. The motivation is that often we want to find we want Laplace transform of product, right? So far, when this is Tn or exponential or or step function, we have formulas. But yeah, but often we cannot always do this. So here's an example. So the plus transform of sine t cosine t is equal to what? Well, use the product formula. So sine 2t over 2. And so you get 2 and then s squared plus 2 squared and 2. So s squared plus 4. But on the other hand, sine t and cosine t. Well, the first guy is 1 over s squared plus 1. And the other guy is s squared plus 1. So you can see that that these are not equal, right? This is s squared plus 1 squared s. Good. But we have something close to that. So a definition, the convolution of two functions, ft, gt, is as follows. Right, so f tau gt minus tau d tau. So this is the convolution of fg. So here's the following theorem: the Laplace transform of f convol g. So 0 to infinity, e minus st. We get the double integral. So now we will swap the integrals. This is tau, this is t. This is the integration region. If you fix t, then tau goes from 0 to t. But if you fix tau, so if you fix tau, t will go from tau to infinity. So we swap. Okay? So tau, and this is t. Good. Well, this guy depends on tau, so we bring it up. Now here we do a change of variables, t tilde equal to t minus tau. And finally, we bring out the exponential. And we can write this as t, because it's a dummy variable. Good. So this is nothing else but the Laplace transform of f times the Laplace transform of t. And that's it. Okay, so now let's do some examples. So one good property of this is avoids having to do, so it turns partial fractions into integration. So what do I mean by that? So very often you have a problem like this, right? 2s s squared plus 1 times s plus 1. And you do your partial fraction and you have some terms, right? Good. But now we will solve this problem using a convolution. All right. Recall from the table that the Laplace transform of cosine is equal to s squared plus 1. Okay? And the Laplace transform of e to the minus t is 1 over s plus 1. All right. So this is nothing else but so let me call this f1s and f2s. Let me put a 2 as well here. So we have f1s times f2s. Okay, so we have product of Laplace transforms. So that turns it into convolution. So actually, let me write it as capital F. I'll write this as small f. Okay, so then it will be the convolution of the small f. Okay, so 0 to t, 2 cosine t times, x, tau, same as in the book, a minus t minus tau, d tau, okay? Right, so this is f1 tau, and this is f2 t minus tau. All right, and so I did the integration for you. and this is 1/2 e minus t plus sine t plus cosine. And that's it. That's the answer. So if you did partial fractions, you will have got the same answer. So it's up to you, whatever you're more comfortable, integration or partial fractions. All right. Let's do another example. Solve the IVP y prime y plus integral of 0 to t y tau d tau equal to f of t, and then y0 is 0, y prime 0 is 1, and ft is the following. It's 0 when t is less than pi, 1 in between, and 0 after. Right. So we've seen this example before, this forcing. It's the difference of these two step functions. Okay, good. So the tricky part here is this integral operator. So call it star and take Laplace transform of both sides of star. Good. Let's see what happens. So we have Ly prime, Ly, L of the integral, and L of f. You already seen this. This is nothing else but S Ly minus y0. So, and then I have to find this. Okay, so now this is a convolution of the constant function 1 and so I have y convolved with 1. Okay, so, and we already know what this is. L of y star 1 is just the Laplace transform of y times the Laplace transform of 1. Okay, all right, so let me group everything together. Solve for Ly. If you do that, you get the following. LF y0 and then s plus 1 plus 1 over s. Okay, so the question is find yt. Which is this. All right, I should say a little bit more. So L of the step functions. We did this in the previous clip. The shift, the translation theorems, second translation theorems. This is nothing else but e to the minus pi s over s, e minus 2 pi s over s. Okay, good. Right, so returning to this, we get the following: e minus pi s, s squared plus s plus 1, and 2 pi s, s squared plus s plus 1. Okay, so this is yt. If you find this, you find the solution. Now, how are we doing? Okay, so let me, because this doesn't use any convolution techniques, let me just give you a hint. S squared plus s plus 1 can be written as follows. 1 s plus a half squared plus 3/4. Okay, why is that useful? Because this is the shifted so this is sine of square root 3 over 2 t s plus a half, right? So from the translation theorem, this is e to the minus t a half sine square root 3 over 2 t s. Okay, so that's the hint for this. And let me give you the final answer so you can check. So it would take a while. So we have 2 square root 3 step function to the minus t minus pi over 2 sine of square root 3 2 t minus pi. Okay, that's one term. And then the second term is ut minus 2 pi. So everything is with 2 pi. So exactly the same. Okay, so that's the final answer. And they're both transient. So they go to 0. Okay, so I want to have some time to at least do one more complicated convolution example. So this is from your book, exercise 48. So they ask you to solve, find f of t and t minus equal to, so t minus 2 f of t times the convolution of these two. D tau. Okay, so this is the convolution of ET with f. Okay, so let's do this. Take LT of both sides. So we have LT minus 2 L of f, and then L of the convolution. Okay. Right, so first guy here is 1 over s. This guy, call it capital F of s. And this becomes the product. Right? So now solve for F of s. So where is it? Yeah, so 1 over s equal to plus 2. So F of s is 1 over s squared, sorry, divided by this. Now these are just exponentials, so let me save you the trouble, and if you do all the computations, you get s squared minus 1 over 2s to the 4. Okay? So that's what you get. First guy is 2s squared. Second guy is 2s to the 4. So use the formula Laplace inverse of n factorial, Sn plus 1 is t to the n. So where am I? So yt is equal to Laplace inverse, sorry, ft 2s squared, 2s4, so this is t, and this guy requires to divide by 3 factorial. So t to the 3. And that's the answer. Okay. So that's it for convolution.